Hello everyone, let's solve the next question. Here we are given two cars, car A and car B. Both are moving simultaneously along the same direction, and here we are given that the initial velocity of car A is 0 and its acceleration is 4 meter per second square, and its initial velocity is 1 meter per second and it is moving constantly with 1 meter per second. That means its car B has acceleration 0, and at t is equal to 0 its speed is 1 meter per second and it is constant. Now we are given that at t is equal to 0, that means initially A is 10 meter behind B. That means the separation between these two is 10 meters. Now we have to find the time when car A overtakes car B. Since both the cars are moving, let's analyze the motion of one car with respect to another. That means we use the concept of relative velocity or relative motion. That will become easier. Suppose we analyze the motion of A with respect to B. That means B is our reference frame. Reference frame is that point from where we observe the motion or we analyze the motion. Then we will assume B to be at 0, and with respect to B we will calculate everything. Suppose first of all we find initial velocity of A. Initial velocity of A with respect to B. Before that, let's assume that this direction, this rightward direction, as positive and this direction as negative. So initial velocity of A, UAB, is equal to UA minus UB. This is initial velocity of A with respect to B. B is our reference frame. So here we can see UA is 0 because initial velocity of A is 0. So 0 vector minus UB is 1 along this direction. This direction we have taken as positive. So this is minus 1 meter per second. Then we find acceleration of A with respect to B. This will be acceleration of A minus acceleration of B vector. So acceleration of A is 4 along this direction minus acceleration of B is 0 vector. And so plus 4 will be the answer because it is along this direction. Then we find displacement of A with respect to B. We assume this to be at rest and A will come and reach point B and overtakes B. So it covers a displacement which was initially 10 meter. So we can write displacement of A with respect to B is equal to SA minus SB, which is equal to 10, and this is the initial point and this is the final point. So displacement vector will be along this direction, so it is plus 10 meter. Plus 10 meter. Now we have to find the time when car A overtakes B. That means when car A reaches this point, because this is our reference frame. Suppose at t is equal to t time it reaches point B or it overtakes car B. So we can apply the equation of motion S is equal to ut plus half a t square, since here acceleration is constant or it is a case of uniformly accelerated motion. Let's rub the board. Here we have SAB is equal to 10 meter. So we can write here S is equal to UT SAB is equal to UAB times T plus half of AAB times T square. So displacement of A with respect to B is 10. Initial velocity of A with respect to B is minus 1 times small t plus half of plus 4 times t square. So we have got 2 times t square minus small t minus 10 is equal to 0. So by using the quadratic formula, we have t is equal to minus 1, that is 1, plus minus root under 1 minus 1 square, that is 1, minus 4 dot 2 dot minus 10, that is 80, and it is going to be plus 80. So we are getting 2 dot 2, that is 4. So here we are getting 1 plus minus 9 upon 4 or 1 plus 9 upon 4, that is 2.5, and 1 minus 9, that is minus 8 upon 4, that is minus 2. So one value we are getting as t is equal to 2.5 seconds and another value is t is equal to minus 2 seconds. Since time cannot be negative, so this is not acceptable. So this is the correct answer, that is time is equal to 2.5 seconds. So here we can write, after 2.5 seconds car A overtakes car B. In this way, using relative velocity concept, we can easily solve such type of questions.